Hello everyone, I hope you're doing fine and enjoying the new Blender 5.0. Today I wanted to talk about the new closure node and my opinion on that. I watched a video a week ago that was made by Depict Labs. It's this guy. Make sure to follow his channel, subscribe to him. He was trying to explain the closure nodes, and it gave me a good idea to show you more capabilities of that. In my opinion, it's still new to me, and we were talking about how can we implement the closure nodes. So I've decided to make a video about it, and I found out some beautiful things here, and I'm gonna share them with you. In my opinion, to create a modular workflow in geometry nodes in larger scales, the closure nodes can be very good. They can inject new parameters inside our existing groups basically, and they can tidy up our workflow and speed it up and clean it up at the same time, I guess, because they prevent us from creating redundant copies or output sockets from group nodes, and maybe avoiding some loop dependencies. I was thinking about creating a workflow, a simple workflow that can emphasize on injecting something into a simple animation. And during creating that, I realized there are some very, very good benefits in using closure nodes. Imagine we have an input and output from our animation. This is our simple workflow. And there is a cone, for example, which moves from left to right. And we have action A, B, C, or they can be placeholders. I think we can think of the closure nodes like placeholders in our modular workflow as well, because they are very versatile in updating and creating new outputs. For example, we have a simple animation diagram here, and we're gonna create A to B and C placeholders and one output. And then later the director, for example, can decide what's gonna happen to A, what's gonna happen to B, and what's gonna happen to C. But we need to create our workflow as fast as possible. So it can lead us to this diagram. For example, we have pool of ideas. They can be, I don't know, spread, scale, rotate, delete, random, etc. It can be whatever we want. And we can inject them easily inside these actions or placeholders and then output them. This is our little cone I've created. This is gonna move from left to right. And when it gets to the A square, it does, I don't know, action A, action B, action C, and then the output. So basically, I've created three versions of it. First, I've made this closure method here, some spread, scale, and rotate actions, or I don't know, things in a modular workflow, and gave it a material and the output. And I've decided to recreate it with the group nodes. And it was then that I realized I cannot inject these separate groups and inject them here and use them in our workflow. So our workflow here in the closure method is basically something like this. In a simulation, it's gonna move from left to right. And then when it gets to A, between frames 10 and 90, frame to B, 110 to 190, frame C, 210 to 290, and then the output. So I've got our closures, and with evaluate closure, we can output some data. So basically the logic behind it is if it's between these frames, use whatever is injected inside A. If it's B, use this one. If it's C, use this one here. So this is the basic logic for this master group. And now we're gonna go to the closure and play our animation. As you can see, this is spread. This is some random scale. And this is some random rotations. Very simple. The beauty of closure nodes are I can swap them easily. For example, I can say spread should happen to B, scale should happen to A. And when I play it, you see the scale is happening when it's achieving A, spread B, and rotation on C. Very easily done. Very, very easily done. This is inside of them. There's only basically this closure without any special inputs and outputs. And you can, by the way, export attributes from your whatever doing here and expose them inside the closure or expose them to your group, which I prefer to use the closure because I can use on the receiving end. So when I try to use the group inside version, it's gonna do the same spread, scale, and rotation. And the logic, as you can see, I've decided to output this scale, which I had in my closure node. And we're gonna talk about it later. So when I open this, you can see that I have my groups for spread, which are not inside a closure. They're simply one input and output, scale and rotation. If I, for example, wanted to change the spread and scale actions, I can remove that here. I can remove this one here, connect this here, and bring it here, do the same, bring it here. And this is basically what I can achieve. You can see it's gonna take more time to reconnect everything and create our logic here. But an interesting part was when I decided to try the injecting method, I can open this group. You can see, okay, we have A, B, C here. And when it's achieving this frame range, it should switch to this object and B and C like this. But the problem is that because it's doing it after the simulation, but receiving it from outside of this group, basically the simulation is not happening when I try to play it. We can look at here. It moves and stuck here and moves again. It's stuck here and moves and stuck here. So clearly this is not working. We cannot inject them here, or we should make a mess. We need to output something like this we had. We need to create output here. For example, when I'm using this one, it should receive this. And basically I should create an output here for A. If it's not, output here for B. And output here for C. And you can forget the naming here. If I connect this here, you can see we cannot have that. a loop is gonna happen here, which we cannot do that. But with the closure node, I want you to pay attention to the input geometries. In my closure node, I don't have any geometry input. It basically receives the geometry in the middle. And this was fascinating me, to be honest. I had the option to create an object collection, or for example, let the user pick whatever option he wants and choose it and expose them here inside the closure or the group. But seeing that without any node inputs from the main geometry, I was able to get that action A, for example, or B injected inside this sequence. And a beautiful part about the closure nodes is that I can, for example, I want to capture a position, output them here. Or I can simply output the simple geometry unchanged. And you can see there's a refresh button here. Be careful, if I press this, I will lose all of this data here. It should be refreshed on the receiving end. We're not on the receiving end, so we're not gonna refresh this. So we're gonna head back, go inside our closure node, and it's connected to A. In the A, when I refresh this here, you can see easily I have exposed these parameters. I can use the unchanged one, changed one, or for example, get the position data and do whatever I want with it. And I think I can use, for example, this one here, this min and max, and go back, come here and refresh and get those here. And in my opinion, this is very, very interesting. This is very nicely done. And I can use this simple connection to expose all of these parameters from here to here. It's acting like a bridge for me. It's a placeholder, keeps all of this logic inside this closure node. Basically, I expose this scale value inside the group to see what's happening. If I do that, I want to be able to control the scale value outside of this group. So I exposed it here, but of course I could do that this way too. I could connect this inside this closure and go here, hit refresh, and change the scale here. I have full control over it. So I think closure nodes are very good to create modular workflows and give us really clean, and at least from my experience, they can remove redundant loops or errors like this. So this was my take on closure nodes. Feel free to add to this new feature in Blender and share your use cases. Let's enjoy Blender together more. Have a good day. Bye.